So today I'm going to discuss Saga design pattern, which is used in the distributed environment in the microservices. So let's begin. The first question is, what is the Saga design pattern and why would you use the Saga pattern instead of traditional database transaction? So the Saga design pattern is a microservices architecture pattern that manages distributed transaction by breaking them into a series of smaller individual transactions or sagas. This pattern is particularly useful in distributed system where managing asset, that is the atomicity, consistency, isolation and durability properties across multiple services is challenging. Now let's see that if in a monolithic architecture all the functionalities are a part of a single transaction. So it is very easy to maintain the asset property of a transaction because either they all are successful or they together gets rolled back. So in microservice architecture, what we have that you have many microservices and each microservice has their own database. So the transactions are distributed among these database. So here in this example, it's an e-commerce example. If you are, the sales is responsible for creating an order. Now, after it's done with its part, it will send an event to the stock that whether it is successful or it has failed. If it is successful, it will proceed with the stock will run the update inventory, and this way the entire transaction would be processed. Now, if in case any of the transaction uh, fails, what happen? You have a compensation transaction. Like each microservice will have two processes. A successful process, that is the transaction, and the other one is the compensation transaction. Like for example, for sales, either a create order would be executed or a cancel order would be executed. Now, the Saga pattern is used instead of traditional database transaction to ensure data consistency across multiple services when executing a transaction. Reliability, the Saga pattern ensure data consistency across all the services. Scalability, scalability means that if you want to add another microservice, then the asynchronous nature of Sagas allow for better scalability. Resilience, failure in one services doesn't bring down other services. That means if any of these services fails, the entire application won't go down. Only a partial transaction will fail. The next one is loose coupling. That means services act based on event, not directly request from other services. That means each services are not directly sending request to another service. They are not tightly coupled, but they are sending events, success or failure events. And according to that event, the next services they process their functionality. The next question is, what are the types of Saga design pattern? So there are two types of Saga design pattern, choreography and orchestration. Now, what is a choreography pattern? In a choreography approach, each microservice involved in the saga knows the subsequent action to take when a transaction complete. These services communicate using events, often through a message broker like Kafka or RabbitMQ. So you can see that these services like service A interact with service B using some message broker. They send their message to message broker. When a microservice completes a task, it emits an event that other microservices listen to and react to by performing their own task. So if a microservice is successful, then they send a success event. If they are fail, they send a failure event, and according to that, other microservice execute their task. Now, in this orchestration pattern, in this approach, a central orchestrator or saga manager. See, this is an orchestrator which is a itself is a microservice, which is a coordinator microservice. So each services do not interact with each other. Instead, they interact through this orchestrator manager or saga manager or orchestrator uh, microservices. This manages the sequence of event across services. The orchestrator explicitly defines the workflow and issues command to services. Each service completes its task and report back to the orchestrator. Now you can see that here services are not interacting with each other. Instead, they are interacting with this orchestrator microservices, which is a coordinator. Now, other question can come that what are the advantage and disadvantage of both patterns? Now, in the choreography pattern, the advantage is it's good for simple workflow that requires few participants and don't need coordinator logic. So, if you have very few microservice, then you should go with choreography pattern. It does not require additional service implementation. So if you are not using any coordinator pattern, you don't have to write an extra microservice logic. It doesn't introduce a unique point of failure. You can see in the orchestration pattern, this is a central coordinator microservice. If it goes down, your entire system, entire transaction will fail. So this is known as a single point of failure. But in the choreography pattern, if any of the services goes down, then there would be a partial failure. Your entire system won't go down. So this is one advantage of choreography. Now there are few disadvantages also. The workflow can become muddled when adding new steps because it's difficult to track which participant in the saga listened to which command. So if you have few microservices and generally you don't add new microservices, then it's better to go with choreography because it's very difficult to add new services to this pattern, and it's very difficult to track the flow of events. Another disadvantage is there's a risk of cyclic dependencies. Since one microservice, like the service A and service B, could be dependent on each other. This is known as a cyclic dependency, which can happen in choreography pattern because they are interacting uh, with each other. So this is one disadvantage of having choreography design pattern. Uh, let's talk about orchestrator pattern. It's good for complex workflow involving many participants or new participants added over time. So it's easier to add a new microservice. And if you have a huge number of microservice in your application, then you should go with orchestration pattern. It is suitable when you need to control each participant in the process as well as the activity flow. So if you want to keep track of all the flow in the transaction, how the event is flowing, you want to keep track of everything, then it is very difficult to do that in choreography. But in orchestration um, pattern, it is much easier. It doesn't introduce cyclic dependency because the orchestrator depends unilaterally on the participants of the saga. So they do not interact with each other. That is why cyclic dependency does not arise in orchestration pattern. Saga patterns doesn't need to know about command issued to other participant. So clear separation of concern simplifies business logic. Since they are not interacting with each other, so what command one is executing, they do not need to know. So all these, separation of concerns, this cross-cutting concerns, it is removed from the business logic, and it makes a code much cleaner. Disadvantage of orchestration pattern: the external design complexity requires the implementation of coordination logic. So in this case, in orchestration pattern, you have to create one more microservice, a coordinator microservice. You have to write all the logic that how they will other microservices or the will interact with each other using this coordinator. So it's a bit complex, and there's an external point of failure. As we have discussed before, there is a single coordinator. So if this itself goes down, then your entire application will get affected and your complete workflow will get disrupted. Now, whatever we have discussed, this is the summary table for that. Uh, it's choreography, it's for simple workflow. Orchestration is for complex workflow. It is decentralized, event driven, whereas the orchestration is centralized, explicit control. Each service respond to event autonomously. The service independence is high. Here it is low because they follow orchestrator's instruction. Error handling: each service handle its own compensation. But in orchestration, there is a centralized handling by the orchestrator. Scalability: scales well due to loose coupling, since they interact using events only, or the services are loosely coupled. Scalable but with more coordinator overhead. Some example: choreography is used in e-commerce. Orchestration is mostly used in banking, transaction, travel booking, or strict sequence. Next question is, how does the Saga pattern handle partial failure? The Saga pattern manages partial failure by using compensation transaction. You should remember this term, compensation transaction, to undo or reverse the effects of previous transaction. In distributed system, each service is responsible for executing its parts of the transaction and if needed, triggering compensation to revert changes. When a service fails, the Saga pattern initiate compensation action in each prior service, creating a rollback effect. This approach ensures data consistency across microservice even in long-running process with failures. So in simple term, each microservice, let's go to the diagram. Yes. So in this example, each microservice should have two process or methods, one for success event and one for failure event. So one, if the success one get the success event, they process the success method, and if they get a failure event, then they execute the rollback method. So that this rollback process or task is known as the compensation transaction. So this way they handle error. Next question is, describe how you would use the Saga pattern in an e-commerce application for handling orders, inventory, and payment. So this is the diagram. Here we have four services: order, inventory, payment, and shipping. So first we have the create order. If it is successful, then you go into the inventory service and execute the reserve inventory. So for the success flow, uh, this is the diagram. And if there is a failure, then these are the compensation transaction. Cancel shipping, refund, inventory released, and cancel order. So this way you can implement Saga pattern in an e-commerce application for handling orders. So these are the explanation of the diagram that you have two process, a success process and the compensation is the rollback process. So every services will have two processes, and depending on the event they get, they will execute the respective processes. Next question is, can you provide some real-time use of Saga design pattern? So a Saga design pattern can be used in banking and finance for fund transfer. Suppose that customer initiates a fund transfer between two accounts. The transfer service send message to the account service to debit the source account and the account service to credit the destination account. So from one account, the money would be debited, and the other account, the money would be credited. But in between, if any steps fail, compensation transactions are initiated to reverse the debit or credit. The next example is travel booking. If you are booking a trip, a customer book a flight, hotel and car rental, the booking service send message to flight booking service to reserve a flight, hotel booking service to reserve a hotel room, and a car rental service to reserve a car. But in between, if any steps fail, compensation transactions are initiated to cancel the respective booking. So that's wrap up our discussion on the Saga design pattern. I hope this breakdown helped you understand how it maintains data consistency across distributed system. If you found this video helpful, don't forget to like, subscribe and hit the notification bell for more interview-based focused Java and microservice content. Thank you.